Scott's Geography Notebook. Did you want to try saying it?
Da, da, da.
We're going to talk about troubles in groundwater. There are a few ideas that I want to touch on. First, there's obvious general water pollution that we can get, and even down in our groundwater, we can get some nasty water pollution. Another problem that we run into is overdrafting, and that leads to a zone of depression. Saltwater incursion, if we are in coastal areas, like we see throughout California, we can have some saltwater incursion, and then we run into what's called surface subsidence, if the overall level of the groundwater starts to deplete. So let's go back to our groundwater model. And you might remember that we have all sorts of good things here. Now, what we could also have here is a little filling station maybe. And up the hill, there's this filling station, and they've got their one pump there, and it's going to be pumping out. But underneath the ground, they're going to have their big tank underneath there. And, oh, yeah, there's the filling station. Okay, this big tank maybe is going to be getting old. And as the water comes down, well, the fuel could also infiltrate down. And as that happens, it can really start to pollute. So old gas stations, there's a lot of things that can lead to this. Sometimes it was just people doing bad things. Sometimes they didn't realize the impact of that. Rocketdyne, for example, near my hometown, rumor has it that when they had unspent jet fuel, they just shot that down into the ground, not really recognizing that it was ruining the water table. Anyway, so we can get this just general pollution down here. So we kind of can ruin the water that way. And so that would be our pollution down here. And even though it goes through, and we like to think that the groundwater is nice and pure and clean and all sorts of good things, it can still get polluted down there. The next thing that can happen is if we have our well, let's go back to, we'll make our little blue wishing well here. And if we have our wishing well, that's there, and it's a cute little wishing well with a little stand there. Good. And we're sending this pipe down below the water table, and it's going to be, let's label that water table. It goes down. Well, let's say that we're pulling a lot of water out of there. What that's going to be doing is it's going to be pulling water from all different directions, from there and there and there and there. And what starts to happen is it actually causes this water table to drip down a little bit, to dupe down a little bit. Now, whoever put in this well built it nice and deep, but for the neighbor that's next door, maybe they built their well that just barely goes into that water table, and they start pulling all that water out. Well, what's going to happen is they could potentially, they're overdrafting, they're taking more water out of the soil than what'll go in. They're overdrafting, and that's causing the water table to actually dip below their well. And we call that a cone of depression. And the reason we call it that is because it actually goes down, right? So we're drawing it two-dimension, and we see this kind of thing. But if we could picture like, and it all kind of flows down, and that's where you've got your well that kind of goes down into that hole, and it's sucked all of the water out of this area. And if your well's not deep enough, then your well's going to go dry, and that's going to be a problem for you. Okay, so we can have water pollution. We can have our cone of depression. Cone of depression. Okay, now the other thing that we see along our coastline is where there might be a lot of wells. If you look along the California coast, there's going to be a lot of people that live there. And all of these different communities perhaps have their little wells in there. Now, we've got good water and we've got bad water. Over on this side, this is water that has been purified and cleaned as it's filtered through those different layers. So this is going to be fresh water. And that fresh water is good. We like fresh water coming into our houses. We like fresh water coming into our pipes and everything else like that. Now, if we look out here near the ocean, this is salt water. It's got really heavy mineral concentration, and you and I can't drink that. And not only that, but it's not going to work for irrigating our crops. And it doesn't really work all that well for those industrial processes. Well, let's say that you've got all these people here, and they're all pulling in fresh water. Well, what that's going to cause to happen is it's going to be pulling water from there, and all this water that currently is kind of at this equilibrium. The gravity is pushing it down, the salt water isn't quite pushing in. Well, what's going to happen is you're going to start to get salt water coming into your groundwater. That's terrible, because salt water is not what we want coming into our pipes, into our houses. And so this terrible process of the salt water coming in is referred to as saltwater incursion. All right, well, those are bad. Pollution in the water, cone of depression from overdrafting. Put that on there. Good. And saltwater incursion, all really, really bad. Okay? We really don't want any of those. Now, what can happen, and it really doesn't work all that well with my diagram, is that sometimes if we pull out the entire aquifer of water, right? So in the Central Valley, we see this. If we pull out all of that water, what starts to happen is the water table starts to drop, right? Which is bad for our wells. But the other thing that can happen is it can take the entire surface, and here, let me do a little folding here. It can take the entire surface and make it drop a little bit down. So it was up here with our groundwater right there. Well, now we pulled out some of that groundwater, and the entire surface has started to go down. And we don't see it, right? We think, oh, we're just driving on the same spot, and sea level and all that good stuff. But over time, scientists have been able to recognize this entire process. And that process is referred to as surface subsidence. And that word always trips me up, so I bring it over here. Surface subsidence. The entire ground starting to drop. So let's make a few quick little notes. General pollutions. Yuckies in the water. Overdraft and zone of depression. Well goes dry because all of the surrounding water was removed. Cool. Saltwater incursion. Oh no. Near the coast, salt water enters the aquifer. Surface subsidence. Oh dear. The entire surface of land sinks because water and the tension that it caused was removed. And that is going to be the troubles with groundwater.